This is John Order, and welcome to my video for Red Green Refactor. This is a video on the Bowling Game Kata, originally created by Uncle Bob Martin. He has a solution out there in Java. I wanted to show the solution in JavaScript and run through it. The Bowling Game Kata is a great kata. You can use it every day to hone your skills as a developer. You can also use it to learn a new language or practice a different code editor or learn new shortcuts and increase your skill in the editor you currently use. So let's get into it. I'm going to go over real quick how to score a bowling game. In case you're not familiar, every bowling game has 10 frames of 2 rolls each, and the bowler is trying to knock down all 10 pins. A spare is when they accomplish that task of knocking down all 10 pins in 2 rolls, and their score for that frame is 10 plus the number of pins knocked down on the next roll. The total score for a game of bowling is a sum of all of the frames. A strike is when the bowler knocks down all 10 pins on the first roll of the frame, and their score for that frame is 10 plus the number of pins knocked down on the next 2 rolls. Keep in mind that for a spare and a strike, it's the next roll and the next 2 rolls that get factored into their score for that frame. It's not the next frame, but the next rolls. So that means if the bowler gets a spare or a strike in the last frame, if it's a spare, they need 1 extra roll in order to calculate the score for that frame. And if it's a strike, that means they need 2 extra rolls. For implementation, we are going to create a class called game, and it will have a roll method and a score method. The roll method is going to be called the correct number of times for a complete game, and it will always be called with a valid number of pins. The score method will be called at the end, and it should return the correct score. Let's look at some examples real quick. This first example is a game of all gutter balls. I've denoted a frame using this slash. So here the bowler rolled a complete gutter ball game and their score is 0. For this next example, they rolled a game of all ones. For every roll, they roll a 1, that's 2 for each frame. 2 times 10 is 20. This next example shows a spare game. So here in this first frame, you can see that they rolled a spare by knocking down 5 pins on each roll. That means that their score for this frame is going to be 10 plus their next roll, which was a 3. So their score for this frame is 13, and then for the second frame it's 3, which means their final score for the game is 16 after rolling gutter balls on each other roll. This other one is a strike. You can see in the first frame they rolled a strike, and then in their next 2 rolls they knocked down 1 pin each, which means in this first frame their score is 12, plus 2 is 14. And then finally, this is a perfect game. There are 12 10s here. There's 2 extra ones because, like I said earlier, when they roll a 10 in the last frame, they need 2 extra rolls to calculate the score for that frame. So here, their score is 300. Okay, with that, let's get into it. Right now I have an empty implementation file, and here's my test file, and I'm going to be practicing TDD here. So I'll be writing a test first, then I will be passing the test and refactor. So we're going to be following the red-green refactor. Let's start with the gutter ball test. Okay, here we're testing all zeros. I'm going to set up a for loop. And for each roll, we're going to roll a 0. At the end, our score should be 0. And I created this game method without declaring it, so let's do that now. And let's import our bowling game class that doesn't exist yet, by the way. Notice how I'm creating these variables without anything existing, so this will fail when I run the test. Okay, let's run this. Alright, we can see here that for this first test, it told me that bowling game is not a constructor, which makes sense because I haven't created any actual bowling game class yet. And I'm going to go ahead and fix that right here in my implementation. Let's create a bowling game class. With that done, let's run our tests again. And now our error is that roll is not a function. Let's create that roll function. And while we're here, let's create our score. And I'm going to be implementing this score as a getter. Okay. So now, right here, we expected that score would be 0, but instead we got undefined. Let's fix that. The simplest way to pass this test is to just simply return 0. And now I could have done this, instead of running the test so many times, I could have just come right in here and created this class, return 0 from score right away. But I took smaller steps just to show a little bit more of the red-green refactor cycle. But now this test should pass. There we go. There isn't a whole lot to do refactoring-wise in the implementation class or in our tests, so let's move on to the next one. For this one, we're going to be doing this test case right here. We're just going to roll ones for each one and see that we should get 20 at the end. Let's see this test run. And just like I thought, we expected 20, we received 0. Let's see if we can make past this test. All we need to do here is basically let's just keep a rolling tally of the pins that we knock down as we go. So in order to do that, this roll gets pins. We're going to create a running score field, and every time we call roll, we will just simply add our pins onto our running score, and then at the end we will return it. Let's see if this passes. And it does. Perfect. So now we have 2 passing tests. Right now our implementation is still pretty simple. All we're doing is tallying up the number of pins that we knocked down. Let's look at our test to see if we can do any refactoring. And it looks like we can. The first thing we can do is we can extract this game variable out. Since we're doing it in each test, this is a perfect place to take that into a before each function. And if you're not familiar with a before each function, most testing frameworks have one. It will run before each of your test cases. So here we're going to create a game variable, and then before each test we'll simply new up our bowling game class, and then we don't have to do it in each one of our test cases. The second thing we can do is we can simplify and extract this for loop into its own function. Let's do that. Let's call it roll many. We'll send it the number of pins and the number of rolls. So for however many rolls that we want to do, we will roll and knock down that many pins. So here we're rolling 1 each time, and in this first test we're rolling 0 each time. And that makes our tests a lot simpler, a lot more easy to read. Let's make sure our tests still pass. And they do. Alright, now we're in a really good spot. Let's move on to the spare case. So we'll roll a spare, and then we'll roll a 3, and we should get 16 at the end. Alright, so we will roll a 5, and then roll another 5, and then we'll roll 3, followed by 17 gutter balls. And the score after that should be 5 plus 10 plus 3 is 13, plus another 3 is 16. Let's see what our test comes up with, and we came up with 13, which is to be expected because remember, we're still simply tallying up our score and then returning that as the result. So now we need to implement the special logic for a spare. But we need some refactoring here first. Right now, this roll method is really just adding up. It's doing the calculation that the score method should be doing. So let's change that. We're going to create a rolls array. And every time we roll, we're simply going to push the number of pins into the array. Now for score, what we want to do is we want to iterate through the frames and return the sum of every frame score. So let's start with a score here. Let's start with a roll index. And then our frame index will be our iteration value. So our frame score will be this dot rolls, our current roll, which is roll index, and then our next roll, which is roll index plus 1. Add that to our score, and at the end, we'll return score. So I haven't really implemented any logic for our spare. We should still be failing here. There we go. Expected 16, but received 13. So now we can see if we got a spare by testing if this frame score is equal to 10. And if it is, then we want to do our spare logic. Otherwise, we'll just do our regular frame logic. But here our score is going to be 10 plus our next roll. So the two rolls for this frame are roll index and roll index plus 1. Our next roll is roll index plus 2. And that passed the test. Okay, let's move on and see what we can do to refactor this to make it simpler to read. The first thing that I always like to do with if statements is I like to extract the condition out, sometimes into a function that makes it easier to read. Here, frame score equals 10. What that really is saying is if we got a spare. So let's do that. Let's do the same kind of idea right here. This is 10 plus this dot rolls roll index plus 2. I want to make this easier to read by breaking this out into a function that is called spare bonus. That's a lot better. So we get our frame score. If we bowl the spare, then our score is the score plus our spare bonus, otherwise simply our frame score. Increment roll index by 2 and go to the next frame. Let's make sure that our tests are still green. And they are. Alright, let's go on to our strike case. Here we're going to bowl a strike in the first frame, then we'll bowl 2 1s, and then we'll bowl gutter balls, and we should end up with 14. So here we have 14 because on the first frame we bowled a strike, then the score for that frame is 10 plus the next 2 rolls. That's 14, that's 12, and then the next frame is 2, 12 plus 2 equals 14. And this test will fail because we haven't implemented the logic for a strike yet. All we have is a spare, so we got 12 instead of 14. Alright, here we are. Here's our spare logic. We need to test for a strike before we get to the spare. So let's go up here. Let's do that. We will say if our current roll is 10, meaning a strike, then our score is 10 plus the next 2 rolls. And we need to remember to increment our roll index. This time we're only going to increment it by 1 instead of 2 because we're going directly to the next frame. And then we need to continue instead of continuing on into this logic. So we need to skip the rest of this, go directly to the next frame. That looks pretty good. Let's see if it passed. And now we're passing. Alright, let's go to refactor. Let's do the same kind of thing that we did for a spare. Let's grab this part and put it into its own function. And we'll do the same idea again, creating a strike bonus function. Okay, much better. Now, for every frame, when we're iterating through, we'll test if we bowled a strike. If we did, our score is the current score plus the strike bonus. We increment our roll index and we continue on to the next frame. If we didn't bowl a strike, we'll calculate our frame score. If that was a frame, then our score is our score plus the spare bonus. Otherwise, just our frame score. And at the end, we increment our roll index by 2. Let's make sure we're still green.